first method we have to graph equations that aren't lines or that we're not sure what the graph looks like is going to be just the plug and chug method. Find a bunch of points and see if that gives you a picture of the graph. So this equation has x squared in it. So I know it's not a linear equation. It's not in slope-intercept form. I need to figure out what the graph of this equation looks like. So I'm going to create a list of points that work in this equation and figure out what the graph of it looks like. Remember that f of x, I'm actually just going to replace this with y because I'm really just finding a bunch of coordinate points. Alright, let's start with x being 0. So if x is 0, y is going to be 0 squared minus 5, so y will be negative 5. If x is 1, 1 squared minus 5 will be negative 4. If x is 2, it'll be 2 squared minus 5, which is negative 1. And let's do 3 in there, and I'm going to get a positive 4 out when I do 3. So here's 4 points. Now, are these 4 points going to give us the, or be able to show us the picture of this graph? I don't know. Let's grab some. These are the 4 points I got when I plugged in x's and found y's for this equation. I'm going to graph these and see what the picture of this equation looks like. So I have 0, negative 5. 1, 2, 3, 4, 5. I have 1, negative 4, 2, negative 1, and my last point was 3, 4. Already I can tell that this graph is not going to be a line. These points right here, the slope between these two is different than the slope between these two, and this one's even steeper. So I could kind of guess that I'm going to get steeper even with this next one. So if I plug in 4, I should get a large number up here because I'm squaring 4. It's increasing really quite largely. But the question is, what happens over on this side when I put in negative values? I don't have enough information with my graph yet. I need to go back and plug in some more points. I want to plug in negative x values to see what's going on the left side of that graph. So I'm going to plug in negative 1, negative 2, and negative 3 into my equation. Negative 1 squared minus 5 will be negative 4. Negative 2 squared minus 5 will be negative 1. And negative 3 squared minus 5 is going to be positive 4. Let's take those new values and plot those on the graph. Okay. So when I plugged in negative 1, I got negative 4 out. When I plugged in negative 2, I got negative 1 out. And negative 3, 4 is the last one. This is really interesting to me because this side of the graph is exactly the same as this side of the graph if I think about like being symmetrical along this y-axis. So it seems that if I were to plug in a number like negative 4, it'd be somewhere up in here, as would be positive 4 over here. I'm going to connect these, trying to make it kind of a smooth curved line, and this is actually the graph of this equation. It continues up in this direction. It does not continue down in this direction at all. There's a minimum point right here. These types of graphs are called parabolas, and anything that has an x squared term in it will have a graph that is a parabola like this. Let's take a moment to talk more about what a parabola is. A parabola is the graph of any function that has an x squared in it. Okay? Now, the interesting things about these parabolas is that they have a minimum or a maximum value. Right here, the graph dips down and then starts coming up again. This is the point, this bottom point, we call the vertex of the parabola. And in some parabolas it's a minimum, and in some parabolas it's a maximum. And we'll take a look at those in a second. But for right now we want to know that this is the vertex. The vertex of the parabola is the bottom of the graph. It's a minimum value in this case because the graph doesn't go beneath any of these values down here for the negative y values. So let's say this vertex right here is a point, and it's the point 3, negative 1. So we can identify the vertex being that point. The minimum value of this parabola is the y part of it, so the minimum value is going to be negative 1. The line of symmetry, and this is another important aspect of parabolas, is the fact that I can draw a vertical line through the vertex And this graph is symmetrical from this side to this side, right? Any point on this side is reflected over here. This point right here has a pairing, and it's right over here. This point right here is over here. So this graph I can split in two, and it is symmetrical. So the line of symmetry happens at the vertex, and that's going to be the line x equals 3. That's this vertical line. Let's find the vertex axis of symmetry and least value of a parabola without graphing it. From the previous slide, we learned that there's a formula for the x-coordinate, and that formula is negative b over 2a. B and a are coefficients from the standard form of a parabola right here. So for our example, b is going to be the number in front of x, which is negative 1, and a is going to be the number in front of x squared, which is 1. So the x-coordinate of our vertex, if I plug in b and a, will be, well, negative 1 is just positive 1. 2 times 1 is 2. The x-coordinate of our vertex is 1/2. To figure out the point that the vertex is in, I need to figure out the y-coordinate of that vertex. And remembering that y is really the same as f of x, I just need to plug 1/2 in to the equation above. So 1/2 squared minus 1/2 minus 6. This is 1/4 minus 1/2 minus 6. This is, whoops, you can't see, negative 6 1/4. That means the vertex of my parabola is positive 1/2, negative 6 1/4. So I'll write that here. Now the next piece of information I need to know is the axis of symmetry. If you remember the sketch of a parabola that we talked about before, the axis of symmetry is this vertical line that splits the parabola in two, this dotted line that I just drew in. This vertical line goes through the vertex, so it's going to have the same x-coordinate as the vertex. It's actually going to be the line x equals 1/2. Any line that doesn't have a y in its equation, it's just x equals 1/2, is a vertical line. We chose 1/2 because we want it to go through our vertex. We're going to use the vertex again to figure out the least value of this function. The least value is right here at the vertex, and we're talking about the smallest y value that it hits. So it's going to be the y-coordinate of the vertex. The least value of this graph is negative 6 1/4. Let's try another example like this. For this equation, to find the vertex, I use the formula x equals negative b over 2a. For this example, b is negative 3, so it's negative 3, over 2 times, and in this case, a is negative 1. So that means the x-coordinate of my vertex is positive 3 over negative 2, or negative 1.5. To figure out the y-coordinate, I plug it in to the function. So I want to know what f of negative 1.5 is. So it will be negative 1.5 squared minus 3 times negative 1.5. This, when you work out all that math, becomes 2 1/4, or 2.25. Depending how your calculator handles fractions or decimals. So that means the vertex of this parabola is at the point negative 1.5, 2.25. The axis of symmetry, remember, is the line, the vertical line, x equals the x-coordinate of your vertex. The greatest value of this, now this is different than the last problem we did because it says greatest value. The greatest value is still the y-coordinate, but let's talk about why it's a greatest value. In any parabolas, I'm going to make a little note down here, where A is negative, like this example is, the parabola is going to be downward facing. If A is positive, the parabola is going to be upward facing like this. This is why in this example we have a greatest value of 2.25, because the vertex is up here and that's the tip of the graph and everything is below that point. In the last example we had the vertex down here and everything above that. We now have all the tools we need to graph the equation of a parabola. Given this equation, I know that it's going to be a parabola because I have an x squared term. I'm going to start by trying to find the vertex of that parabola. And the vertex, I can use the equation negative b over 2a. In this case, b is negative 5 and a is negative 1. So that means the x-coordinate of my vertex is 5 over negative 2, or negative 2.5. To figure out the y-coordinate of my vertex, I'm going to plug in negative 2.5 into the equation. So y equals negative 2.5 squared minus 5 times negative 2.5 plus 6. When I work out all that lovely math, I'm going to get 12 and a quarter, or 12.25. Oops. To be the y-coordinate. That means my vertex is at the point negative 2.5, comma, 12.25. Let's start by graphing that. Now my grid paper only goes from negative 10 to 10 in either direction, so in order to graph 12.25, I'm going to start skipping by 2's. So my vertex at negative 2.5, 12.25, so 2, 4, 6, 8, 10, 12, and a little bit more, is somewhere right around here. That's the vertex of my parabola. I know that my parabola is going to be symmetrical about this line right here. Now I know that this is the top of my graph and that's very helpful, but I don't really know how wide the graph opens up or if it even opens down this way. So I'm going to go back to the equation and try to find some more points. Now it seems that my graph is going to open downward, and I can verify that because the coefficient in front of the x squared is negative. But I need to get the other side of my graph. Now I could plug in more points, and I could plug in points on this side like negative 3 or negative 4 or negative 5, or I could use the fact that the graph is symmetrical, and I can just reflect this point over here. Since this point is 2.5 away from the vertex, if I go 2.5 this way, I can get another point. So this is the point negative 5, 6. It's 2 away, or it's 2.5 away from the vertex, just like this one is. This point down here, the 1, 0 point, is 3.5 away from the vertex. So if I go 3.5 this way, I'll be at negative 7, 0. And that's another point on the graph. Now I have the vertex and 4 points, and I have the graph of my parabola.